My name is Matthew Chan, and I'm from a small school in New Jersey named New Providence High School. And my project and presentation is on bias detection in AI systems. So before we start, I would like to extend a special thank you to Professor Chirag Lala and Mr. Aaron Kumar, who have both helped me immensely with this project. So they have provided me with valuable guidance throughout their time working with me. I really could not have done it without them. But just a quick introduction of this topic. There has been extreme influence of artificial intelligence across the whole world and has really brought the critical challenge of having a widespread prevalence of biases within these AI systems. So, on the left-hand side, you can see different and specific ways that AI systems can fail. Confirmation bias, for example, is when an AI might seek out or favor data that confirms its pre-existing conclusion. So basically, it recalls historical information that may have been biased. Um, then we have recall bias, which is when an AI overrepresents certain outcomes because they are more frequent in the training data. So this could lead to skewed responses, targeting certain races, genders, and all types of discrimination, which is not a good thing. But the list of biases that a lot of these systems exhibit is much longer, but it is a persistent issue in real world application. So it really actively amplifies and perpetuates stereotypes and discrimination in, when it's in AI. So AI increasingly drives critical decision making. So we do need a robust mitigation strategy to solve this issue. But to truly grasp the gravity of the situation, let's consider some real world examples. So, for example, Amazon's recruitment algorithm, which was used to efficiently hire individuals, was shown to accidentally favor male applicants over equally qualified female candidates. So, this would perpetuate gender bias in hiring in specific. Then we have the correctional offender management profiling for alternative sanction systems. So what this really did was to determine reoffense probabilities, but it disproportionately labeled Black individuals as high risk at twice the rate of white defendants, purely based off of race. So these incidents itself are not isolated, and is a tangible effect on individuals' lives, and it does need immediate and practical and effective solutions. So our solution that I've been working on is a modified version of a popular natural language processing framework for detection and classification of biases in AI tasks. So the baseline for this study was named the D-bias model. So while existing bias detection models have been able to detect certain biases, they often remain inaccurate and struggle a lot with intersectional biases. So our approach was to fine-tune the D-bias model to enhance its capabilities for multi-category and intersectional bias detection in order to have a fairer and more diverse use of AI. So before we get into our findings, let's just talk about current bias detection advancements. So for example, in 2017, the word embedding association test was created, and it was a test to analyze biases at the sentence level that was exhibited by AI. So it showed that AI can create human-like biases and are transcribed into natural language systems responses. So it shows how they accidentally capture societal prejudices. Now, there have been many other notable attempts at this issue, uh, other than the word embedding association test, but a lot of it varied from different data sets to help, which had a lot of biased data to help train future models like classification system. So that would include something like D-bias. But speaking of D-bias, let's go a bit deeper into it because it's so essential to our project. So in recent years, classification models have utilized a lot of complex models like Google's BERT. So DBias in specific does not use BERT, but it uses something very similar called Distill BERT, which is an updated model of Google's BERT, which I'll get into a bit later. But this really allows for different models to be fine-tuned and be created into something like DBias. And DBias in specific is able to identify whether sentences are biased or unbiased to really help mitigate a lot of these issues. So, but it does have its limitations. A lot of them ha struggle with complex biases, and performance was moderate. So it demonstrated how it could have a lot of potential, but it did need significant improvement. So the core of the architecture for the deep bias model was on the Distilbert framework. So this was really what the deep bias model was initially fine-tuned on or with. So it had Distilbert in specific has 40% less computational resources utilized. So that could be very helpful when computational resources are limited, including in our project. Because DBias was trained on it, we were also able to use less computational resources. And it also had a sequence length of 512 tokens to really help pick up a lot of responses, and in specific with DBias, biased responses. So the MBIC data set it is what the Distilbert model was fine-tuned with. So this really allowed the DBias model to utilize a lot of data analyzed by different annotators, and a lot of this data was crowdsourced. So it was a very meticulous process, and it was one of the things that made this data set very reliable to help fine-tune the DBias model. And while it does cover media bias, media bias is very, very similar to the types of biases individuals will see with AI models. But onto our updated model. So in order to update the DBias model, we utilized a data set very similar to MBIC. So the news media bias data set focuses similarly to a lot of media bias, which again is very similar to the biases that AI would exhibit. So it had over 30 distinct bias categories and has over 3.67 million rows of data. So it had for our purposes, we approximately used 11,000 labeled examples to fine tune our model, especially since this data is so big and with computational resources being a big issue, we used a small part of the data. But it incorporates a lot of data from several sources and uses very reliable system like active learning systems to for like human verification to help label a lot of these biases. So it really just tells us how biased this statement is, and we can easily sort it whether it is biased or not. Now, for the fine-tuning process itself, it involved many key steps. So first, the data was reformatted and tokenized to ensure that it matched the DBias model's requirements. So it had a 512 token limit because it was trained on Distilbert. And the original DBias model functioned as a binary classifier. So because the data set had labels such as neutral, we put those towards a non-biased result, which is mapped to 0. And we made slightly biased and highly biased correlate just to one bias category, and we label map that to the number 1. So uh, it also had a learning rate of 5 to the power 5. So we inputted this into the trainer API just to tell it how fast to fine tune the model. And we also used a batch size of 16, which really means that that's how many pieces of data it takes at once to learn. And it has 20 epochs. So that's how many times the 11,000 lines will cycle through the data. So it'll cycle through it 20 times. So for our results, uh, it was very successful after our fine tune. So here in this chart, it was based off of a sample of 2,200 lines on the news media bias data set. So it did very well in terms of accuracy for different bias categories that was presented. So because it was a relatively smaller sample, some categories weren't given enough examples. So were some abnormal results like 0% in sexual orientation, but that's just simply because there weren't enough, it wasn't a big enough sample size. But as the sample size increases, those numbers will return to normal. But for the most part, it did very well in most categories in identifying things like hate speech and religious bias. But it did struggle a bit more in areas such as personality bias. Um, so we wanted to compare different AI models to compare our results. So we compared the updated D-bias model, the original D-bias model, and the Distilbert model, which were all very key parts of this project. So the Stillbird itself had not gone through any specific bias training. And as you can see in both the NBIC data set and the news media bias data set, it had an accuracy of 45% and 48% respectively. So this is expected because it hasn't been trained to see any biased sentences. So its ability to classify them is very random. And the recall score and precision score also reflect that. The original D-bias model, on the other hand, when we tested against the news media bias data set, it achieved a 57% accuracy. But when we were comparing it to the NBIC data set, which it was originally trained on, it performed better with a 67% accuracy and had a recall score of 75%, meaning that it was fairly effective at identifying biased lines, but did have a lower precision score of 65%, meaning that there were also a notable amount of false positives. Now, for the main results from our updated D-bias, when we tested it on the news media bias data set, which is what we trained it on, uh, the accuracy jumps from 57% all the way to 83%, which is approximately a 26% improvement over the baseline. So all the metrics were showing the recall and precision score when we tested the updated D-bias on the news media bias data set. Um, but when we tested it on the NBIC data set, we realized that there was an important trade-off that the recall score for on that data set itself was 93%, meaning it was extremely effective at identifying biased content. But it also suffered in accuracy and precision, having 60% and 56% respectively. So this phenomenon is likely due to what we call catastrophic forgetting. And in fine-tuning a model extensively on a new data set, we appear to have overridden some of the original learning data. So that is definitely something for future research to improve. But just a quick discussion. There, as you can see, there are many, many limitations with even our updated model. So there is a need for enhanced tokenization and classification because to detect a lot of these difficult and subtle biases that AI continues to produce and that our previous models may have missed. So we also may need to expand into multilingual capabilities in languages such as Spanish and Italian. A lot of those languages remain to be untested. So that is definitely something people need to expand on. And just in general, continue adaptation for long-term effectiveness and as well as just catastrophic forgetting. As you can see, it was detrimental to our results. So that is definitely something that future researchers have to consider with specialized regularization methods. So building off of those limitations, in future works, is definitely a need to mitigate the issue of catastrophic forgetting. So different regularization methods like the elastic weight consolidation method, which really helps give previous data and allows the model to continuously learn off of the previous original data when being fine-tuned. And then we hope to see that there's expansion in multilingual capabilities just to have a tool for the world and have it on a global scale. Also, implementing real-time bias monitoring would enhance the model and would allow it to be continuously updated with the latest biases as they continue to emerge and evolve. and overall just continuous improvement. Our work is really focused for researchers and practitioners to use this AI to detect different biases in AI systems, and it's definitely something that needs to be refined further. Now, beyond the technical achievements, it is essential to discuss the ethical implications of this work. So, uh, although we did improve bias detection system, it is an instrument to discover different biases and enhance mitigation strategies. So, the goal here is to promote responsible AI development, which is an issue throughout the whole world as of now, especially with more advancements in AI. And this is to augment human judgment to be made in conjunction with human decision making in sensitive context. So it could really help assist human at identifying a lot of the uh, biased responses. And also just identifying unfairness and prejudice to build a more equitable world in a world that's full of dishonest and biased information. So thank you for listening to my presentation. Does anyone have any questions? And here's a works site if anyone wants.
Hey, Matt. Thanks for the presentation. Yeah, there was a question from outside the chat. Um, I'm trying to make sense of it. Okay, how do you validate that debiasing doesn't compromise task-specific performance? I'm not fully sure what that means, but maybe you understand a bit more.
Well, our model simply gives a value whether it is either biased or non-biased. So from there, individuals can take that how they want it. Again, this is simply just to identify whether it is biased or non-biased, not to actually fix the data, which again is something that future research can help to solve.
I see. I think I understand. Yeah, so essentially what you're saying is that this would be wrapped into a language, like a large learning model, like as part of the before the end product.
Yeah, and also just for a tool for future researchers to use when they utilize AI, whether or not it is biased or non-biased, and if they could truly trust it, or if they have to proceed with caution.
Ah, I see. Okay, so going off of that, how do you think that debiasing something could introduce new forms of bias? Like, how do you make sure we're not like overcorrecting, for example?
I mean, again, that's something that Future Works definitely has to focus on, but this is just simply advice, almost like whether it is biased or non-biased. But there definitely comes up the issue when the model is incorrect. Maybe you approach it with too much hesitation.
Mm,
But since it only gives whether it's non-biased or biased, I don't foresee that our model at least will become an issue.
okay, awesome. Yeah. What what are the next steps for the work that the research that you're working on, specifically uh like ironing out the issues with the kind of the bias model that you've been working on, or the bias filter? Like, what's next for it?
Yeah, so as you saw with the data, a lot of it had it struggled with other data sets that it previously had. So like the
Right.
MBIC data set, our updated DBIAS struggled a lot with it. So what me and my professor and TA were thinking were to further fine tune it to help it relearn almost what it previously forgotten. So because through catastrophic forgetting, it forgets what it originally learned.
Right.
So we are thinking of trying to continue to fine tune the model to almost balance its accuracy in both the our new data set that we found, which is a news media bias data set, but also the MBIC data set, since accuracy did decrease slightly.
I see. Is the what did you call it? The catastrophic forgetting? Is that
Yeah, catastrophic forgetting.
catastrophic forgetting, is that like related to like storage issues, or how does that work?
So a lot of it when we're fine tuning a model, we change different weights in like in the neural network, which is how an AI is made. So that
Huh?
is when we adjust that neural network with what we call weights,
Mhm.
a lot of it will be adjusted, but a lot of the times that because in cases of catastrophic forgetting, it will overwrite what it previously learned. So it will just forget like how to solve issues in a data set like MBIC because that data can be very different from something like news media bias, the
Right.
news media bias data set, which is likely why we saw a decrease in accuracy in the MBIC data set.
Mm, that makes sense. Yeah. Awesome. That's all the questions. Is there anything else you'd like to say before we move on?
No, I think that's it. I mean, I thank
Okay.
you for your time.
Yeah, you're welcome. Thanks for presenting through CCIR and good luck on wherever the research takes you next.
All right, yeah, thank you so much.
Yep.